exponential functions. Remember we talked about the log functions? So inverse of log function is exponential function. So we're going to talk about the exponential functions. And then we're going to differentiate this and integrate that. Objective. Develop properties of natural exponential functions. Differentiate natural exponential functions. Integrate natural exponential functions. That's what we're going to do in 5.4. Natural exponential functions. So remember yesterday we talked about this. The inverse function has what? This is my y equal to x line. All right, and as you see it, natural log function and then exponential function, look at how they look like. They are reflected to each other, mirror image, isn't it? Just looking at the picture, you know they are what? Inverse function too. So they are inverse function. Since exponential function is a monotonic increasing, you know you will have what? Inverse function, which is right here, the mirror image. Anyway, class, you kind of need to know what the log function and exponential function looks like. Because this is what they use a lot in economy. Like economy, when they do like a growth graph, they're using this one, right? You grow rapidly, then what happens? It kind of stabilizes, so you don't grow anymore. Like your population grows so much, and then what happens? Kind of stabilize, right? For example, they're using for what? Rabbit and fox. Rabbit grows rapidly, then what happens? Then fox eats up, and then they kind of stabilize their populations. That's what the log function looks like. And then people always wanted to talk about what they want the economy to grow up exponentially. Do you remember that? So look at this exponential function. What happened? It's continuously what? Growing. That's what people like to say. My growth needs to be what? Exponentially grow. Or my bank needs to grow, exponentially grow. Like economic people always like to talk about what? Their business model will make more money. My model will give you what? Exponential growth. Mm-hmm. That's why. You see exponential graph? What does it look? It keeps going up. And this log is what usually used for what? Growth. Smart log. That's a smart log. So is everybody with me? So better know your graph how it looks like. But that's just like a general knowledge. All right, so we know since log and exponential function, they're inverse to each other, the result has to be equal to what? X. Of course, that's going to be X. We know that. So here we go. They're telling you inverse of natural log would be what? Exponential function, e to x. So let's solve this one. So if you want to solve this one, what we need to do is what? Look at this. X is in the exponential place, right? That means I got to bring it down. How can I bring it down? I need to have a what? Natural log in the front. That's right. I got to put natural log in the front. Are you with me? Whenever you see x in the exponential place, you cannot solve it unless you bring it down to where? In the front as a coefficient place. So you have to use what? Natural log or log. So you put the natural log here, you put the natural log. I choose natural log because you have a base e. If it's other numbers, you can use log if you want to. Okay, it doesn't matter. Log and natural log works just fine either way. Now you have this. Is everybody with me? What's the next step? Right. Since it's a natural log, I can bring this one to where? First thing first, this one give you what? I will get x plus, excuse me. This will give you x plus, why am I keep saying e when I want to say x? I'll have x plus 1, and then what? Natural log e. Is everybody with me? You can bring that in the front, right? Then you know natural log e is equal to the same as what? 1. So that is why you only have what? X plus 1. You're looking for x, so you subtract what? 1 from here. So x is equal to negative 1 plus natural log of 7. So because you know what inverse of natural log, what is natural, what's the inverse of e. So you can solve x. Is everybody with me now? Okay. So this is kind of review from what you're doing in college algebra. College algebra, you have learned this, by the way. So solution is -1 plus natural log 7, which is about what number? 0.946. All right? That's what the answer for this. So e to the 0.97, so which means e to the what? 1.946 give you what? 7. That's what they say. What they're saying is e to the 0.946 plus 1, which is e to the what? 1.946. They will give you what? Approximately what? 7. That's what they say. So as you see it, e is what? It's a number. Are you with me? It's not variable, it's a number.
Yep.
So they're checking the solution, make sure that it's exactly the same. Yes, they're same. All right, next thing. If you have a same base, what can you do about their power?
Add.
You can add them. Same thing with you can do with the e. If you have a divided by base, what do? You subtract. Are you with me? If it's a multiplication, you add. If it's a division, what do? You subtract. All right. So because exponential function is inverse function of what? Natural log function. They have what? Same properties, pretty much. They're continuous, but their domain and range is what? Inverse. Look at this problem. I want you to look at this picture. This picture can show you both of them at the same time. Look at this one. What is the domain for natural log? Domain is what? 0 to what? Infinity. 0 not included. Are you with me, class? What is my range here? Negative infinity to what? Positive infinity, isn't it? Now let's look at the exponential function. What's my domain? Domain is what? Negative infinity to what? Positive infinity. What is my range? 0 to what? Infinity, isn't it? As you expected though, right? As you expected, because they are inverse to each other, so your domain and range will be what? Inverse. So this domain become a what? Range. Its range become a what? Domain. Does everybody see that? So exponential function and a natural log function, they're going to have a what? Inverse relationship, right? Are you following me, class?
Yes, ma'am.
So now we can move on. Oh, I'm going too far. So does everybody understand what's going on here, right? And also, did you see it? The limit x approach from negative infinity. Negative infinity, what happened? It approached to where? 0. Look at this. It's keep going to where? 0, right? If you're looking at the positive side, what happened? Goes where? Infinity, right? Infinity, does everybody see that? Look at just the picture. This approach to where? 0. This is approach to where? Infinity. Is everybody with me? Okay. Now, derivative of exponential function. This is the easiest one. You will love it. Because function itself is a derivative. How cool is that? You don't even have to memorize it. Derivative of e to the x is what? E to the x. That's the best thing that you like about exponential function, right? You don't have to memorize anything. E to the x is e to the x. So that means natural log, when you take integral of natural log, it will be the same thing as what? E to the x. All right, next thing. If you have a e to the u means a composite function, not other than x. Like what? E to the x squared. Are you with me? In that case, what do you have to do? E to the u, and then what do you do? Take a derivative of what? X squared. So which is this case is what? E to the x squared, and then what times what? 2x. Are you following me? They use u whenever it is what? Composite function. It has more than just x itself. So you have to take a derivative of that. So let's look at this problem. This is what it is. So what is the derivative of this? I will do what? Exactly e to the what? This. 2x minus u, right? U is your 2x minus 1. Are you with me, class? Now take a derivative of that. What is the derivative of this? 2. That's why you have a 2 and then what? E to the 2x minus 1. So you like exponential functions because the derivative and the integral is what? Very simple. Actually they're same, right? Next one. Now you have this. You remember this. This is a what? In the denominator, it's an x to the negative 1 power. All right, so this one let's do together. So can I rewrite this problem as what? E to the negative 3x to the what? Negative 1 power. Are you with me, class? Because it's a denominator. Are you with me? Okay? All right. So I'm going to say my u is negative 3x to the negative 1. What's my du? They become a what? 3 and x to the what? Negative 2. Are you following me, class? Take a derivative of this. Negative 1 times negative 3 give you what? Positive 3. X to the what? 1 less power give you negative 2. Okay. So if I want, I can write down as 3 over what? X squared. All right. So I'm going to say this is equal to then. I'm going to write exactly same thing. And the derivative is, what is my derivative? This. Are you following me? Is everybody with me right now? Mm-hmm. This is the easiest one so far. Right. Entire things we learned in chapter 5, right?
Yep.
Okay. So you just need to make sure that you take the derivative of which one? That part. All right, so I have to erase this one so I can show you next one. Okay, does everybody see that? Next one. Is everybody good? So they just put this on where? In the numerator, because this is a numerator, part of a numerator. Next problem. All right, now I have to do what? Product rule. Is everybody with me? This is the product rule. You got the product rule. So let's write down. I have so many u and v's. So this time I'm going to use my u to be x squared, my v to be what? E to x, my u prime to be what? 2x, my v prime to be what? 2x. And derivative of x is equal to what? 1. Is everybody good? All right. So now I'm going to use the product rule. The product rule says what? U times v prime plus v times what? U prime. That is equal to, I'm just going to plug it in what the rule says, right? My u x squared times v prime e to the x plus, and then what? E to the x times what? That's right. Times 2x. And I just combine e to the x. And then what do you have here then? X squared plus 2x. Or if I want to combine, I can combine one more, which is x, right? X, e to the x, and then x plus 2. They're all same answer. Are you following me, class? Okay. So, as I said before, you still have to know your product rules, you still have to know what? Your quotient rules, you still have to know all that. Otherwise, you cannot do chapter 5. Because we assume you already know all those. I'm not going to teach you product rules again, right? Because you're supposed to know. So go over your homework problems if you don't remember how to do product rules or quotient rules. All right, let's go over again. You see what, you saw how, you know how they got that? You compare that, you're done. All right, next one, we're gonna do quotient rule. All right, how about we do this problem in a blank page, okay? So we got a little more room. Okay. So u is equal to, I'm gonna use uv, are you with me? E to the 3x. U prime is what? Tell me what u prime is equal to. What's your derivative of this? E to the what? Same exact same thing, and then write down what? 3, that's right. So remember, e to the x is an easy thing to do because you will write down exactly the same thing and then what? Take a derivative of whatever the power that is. Alright, that's my v. Ex plus 1, right? What's my v prime? Derivative of this is what? E to the x. And then derivative of x, just the ones, I don't have to write that, right? Derivative of 1 is what? 0, so I'm done. And then let's write down our formula, according to our formula. That means u e to the what? 3x, v prime, which is what? E to the x, plus, oh my goodness, what am I doing? That I'm doing a what? I need to do a quotient rule. All right, what does the quotient rule says? Quotient rule says what? B squared and then what? B times u prime minus what? U times and v prime. Right? So that's what I'm going to do. So I'm going to write down my denominator first. What is that? E to the x plus 1 to the what? Square. And I'm going to write down my v. What is my v? E to the x plus plus 1. What's my u prime? 3? I do minus this time. What's my u? E to the what? 3x. What is my, is it, what did I do just now? B prime, what's my B prime? E to the x. All right. We good? All right, so it's easier to combine because it's all e's, okay? So first thing first. All right, so what is, does everybody see this one? This and this is what? Common factor? Okay. So I'll bring out the e to the 3x in the front. Then I have what? 3 and then what? E to the x plus 1. And over here, what do you have? Minus e to the x. Everything over what? E to the x plus 1 square. So when I combine this one, does everybody see this one? I can do what? Distribute it. What do you get then? I have 3 e to the x plus what? 3 minus e to the x. Everything over. Of course, same thing again. 3 minus 1 gives me only what? 2. Have a 2 e to the x plus 3, everything over what? E to the x plus 1 squared. We cannot combine. We cannot simplify anymore. Does everybody see it? So we're done. working with the E is much easier than regular polynomials because it's easier to make what? Denominator same. It's easier to what? Factor out. So as you see, this is why how they got this exactly the same as ours. Okay, now let's look at the integration. So we've been doing what? Derivative, let's do opposite way. So of course, since derivative is what? E to the x. So when you take integral is what? Still what? E to the x. Is everybody with me? So derivative and integral, they're exactly what? Same. All right, let's do practice and we'll be done for the day. Let's take antiderivative of this. So first thing first, I need to make sure that I have everything I need. So we're gonna use this to be our u. So u is 3x plus 1. du is what? 3 dx. So I'm gonna rewrite this problem as e to the u, and I have a dx. Are you with me, class? But I need to take everything, the antiderivative in terms of what? U, but I have a dx. What I need is what? du is equal to which one? 3 dx. Am I right, class? So what do I need to do? Just think about the one that you did with the chain. Remember the antiderivative using a chain rule? Anti-chain rule, kind of like that. So I'm going to say, what I need is what? 3. But I don't have 3. So I need to do what? Multiply by 3, and then what are you going to do? 1/3 divided by 3. Now I can say, yes, I have exactly what I need. I can rewrite it as 1/3 e to the u, and then what? du. Then you're going to say, oh, I know what it is. Antiderivative of e is the same as what? E. So my answer is what? 1/3 e to the u plus c. And then I'm going to replace u with what? 3x plus 1. Does everybody see that? The exponential function derivative and then what? Antiderivative is the same, so it's much easier to work with. And by the way, their graph, I want you to memorize because log is the what? Prime example of growth and decay. And exponential function is what? Everybody's hope to grow what? Their incomes or their finance or their what? Anything that you want to grow, that you always want to say what? Exponential growth, because you grow continuously. Good. Is everybody good? Any questions so far? All right. So let's look at them. They're gonna do exactly what we did. Move that, and you have that.